Assalamu alaikum. Today I will be presenting a presentation on the topic applications of derivative, which is assigned to me by my instructor, Sir Abdul Hanan Sheikh. As we all know that derivative is a really vast topic, so I've particularly chosen two or three applications that will be easy for me to explain, and on the other hand, it will be easy for the person who is seeing this. And it will be easy for the person as well who is sitting behind the camera for him to understand what all I am saying. Let's get started. I'm going to be sharing my screen first, so I can show you all the hard work I've put in. So over here, the applications of the derivative, and this particular question is related to DVD sales, like how DVD will sell with the passage of time. So this is the initial equation in terms of t, and we know that t is in years and t is greater than or equal to 0. And number one is the rate of change for sales. Like this means the rate of change for sales as in the passage of time, like how the rate of change of sales will happen, like how will time affect the rate of change of sales. So when we are going to derive this, we are going to do the derivative. So this equation over here is telling us the change of sale at any time. Like this can be 10, like in the forward in the next 10 years, what will be the sale in the next 2 years, what will be the sale. Like all of this is being done with the help of derivative. Now obviously, as we every if anyone is doing business, he will see when will sales peak, when will he earn the most money. So as we all know, when it will reach the peak at the top, we know the tangent and slope is equal to 0, because at first it's going to take a flight, it's going to up, then initially it's going to come down, and it's going to peak at the most top, and at the top the tangent has to be 0. And so we have in the first part we have found the rate of change for sales at any time of t. So we know the derivative is 0, as I have told you now. And when we are going to solve this, we are going to get time is equal to plus or minus 1. But we know that we can't go back in time, so negative 1 will be rejected and positive 1 will be taken. So in the first year, the sales will peak. All of this is being done with the help of derivative. Now, how fast will sales increase when movie is released? I've written over there when t is equal to 0. Obviously, in the question, it is being said when will the movie release. It hasn't been said that the movie is released. So obviously, the movie if the movie hasn't been released, so the time is going to be 0, and it's being said is equal to 7. So like this can be 7 million copies per year, or anything like in 7 lakh, or it can be anything. So this is how fast will sales increase when movie is released. So all of this is done being with the help of derivative. Now I will move to the second example. So over here, the first part you can see find maximum height. So like I'm going to explain what's happening over here. Like we all know the fireworks and everything. So obviously we want a firework to go to a certain height so that it doesn't affect the population or the people. So derivative is also being used in the calculation of how far the firework will reach. So this is the equation, initial equation. This is the distance in terms of t, and find max height. We know at max height the velocity will be 0. And when we differentiate displacement in terms of t, we get velocity. That's a general rule that what's happened. So we know that at the maximum height velocity will be 0, and obviously if the velocity isn't 0, then it won't, and it will go in the fireworks will go in the outer space. So the velocity have to be 0. So when we see this, we are going to get at time is equal to 8 second, it will reach its maximum height. And when we put the time into 8 second in the initial equation, not in this equation, because if we will put in this equation, we will initially get 0 again. So we have to put time is equal to 8 second over here, and then we are going to get a maximum height. So as we can see over here, the application of derivative is also being used. Now moving to my third example. Now this is really interesting. Now I know this is a part of business calculus, but I thought of putting it this inside in my presentation. So at first, we need to understand what is marginal cost. Like, marginal cost is a derivative of c into x, and is the cost of producing an additional item. For example, if I'm producing 100 item, what will be the cost of producing an additional item? Like, what will be the cost of producing the 101 item? So that in over here also the application of derivative, the derivative is being used. Isn't it interesting? So as we can see, like, initially we do we are going to derive this, we get this is the cost of producing any item. Like, it can be 10, 20, any item. So if I see, so if I want to see the cost of producing an additional item of an 100 item, so the cost of producing that is 160. If I do, what is the cost of producing one more item, that is 101, is equal to 159.6. If I do the cost of producing the 150th item, it is 140. So in this case we can see that the marginal cost is decreasing, but that won't happen every time. It can happen that the marginal cost is increasing. Obviously, like, whoever is running the business has to see all of these things. And as we can see, derivative is also playing a huge part over here. So I think so my video presentation was good enough, was up to your standards, and I hope you understand each and everything. I have tried my level best to explain each and everything. And with this, I would like to say thank you, and hope to see you back in university soon, inshallah. Allah Hafiz, take care.